Welcome back, everybody. This is the follow-up to the advanced stoichiometry notes. I mentioned that I was going to do the example problem in a second video. Got my water. We're going to get hydrated real quick. Okay. So we're going to be working out that example problem from before. Lithium chloride and calcium sulfide react. You start with 25 grams of lithium chloride. How much calcium sulfide do you need? This is a really simple and straightforward stoichiometry problem. There's a good chance that some of you already have a pretty good idea of how to handle this problem, and if you think you know how to do this, I highly recommend that you try it on your own first, because if you can work through one of these on your own your first try, that's a very good sign. It means you're probably going to be good for all of this stuff. However, we're going to work through this one and just kind of plow straight through. Obviously, the first thing we need to do is we need a chemical reaction. We know that we've got lithium chloride and calcium sulfide. They're just right here. But we do need to actually write out a chemical reaction because we need to make sure we know our ratios, because ratios is the whole thing we're caring about here. Your first step for all of these is pretty much going to be to try to make your chemical reaction. So first, we're going to start. We've got lithium, and we've got chlorine, and then we've got calcium, and sulfide is sulfur. So lithium is a 1 plus charge, chlorine is a 1 minus, calcium is a 2 plus charge, sulfur is a 2 minus charge. Hopefully you're still feeling pretty good about all this stuff, because again, it all builds from here on out. We'll cross our charges. We get LiCl, cross our charges. Remember, we have to reduce these because they're ionic. We get CaS. This is two compounds that are combining together. That means that we're probably going to be working with a double replacement. The only thing we have to check and make sure is that neither of these are water and a metal oxide or a non-metal oxide, and they are not, so we're good. So we've got LiCl plus, leave a gap, CaS, arrow, and since it's double replacement, we're going to swap, and we're going to end up with CaCl plus LiS. Ca has a 2 plus, Cl has a 1 minus, Li has a 1 plus, S has a 2 minus. I'm going pretty quickly through this, but that's because by this point in the year, you should feel pretty comfortable about this. This is the quote-unquote easy part of the problem, and you should be able to do this pretty quickly by this point. Otherwise, you're going to have quite a bit of work ahead of you on some of these problems. So we're going to cross our charges, and we'll get CaCl2, and then we'll get Li2S. All right, now we have to go through and balance it. We've got 2 Cl's and 2 Li's, so we can put a 2 there. That gives us then 1 Ca and 1 S. So we are good. Now I'm going to go through and I am going to add my numbers this time because I need those numbers. Remember, these coefficients out front are my ratios that I'm going to use to convert from one thing to another thing. So let's start now with our amount that we were given. We were given 25.0 grams of lithium chloride, of LiCl. Okay. We want to go from grams of lithium chloride to, it says how much. We're going to assume that that's talking about grams of calcium sulfide. So can we go from grams of lithium chloride to grams of calcium sulfide? Well, no. There's no direct conversion factor for that. And anytime you want to change the element you're talking about, anytime you want to change the specific chemical, that means you have to get it to moles, and then you have to use the mole-to-mole ratio. You have to use the recipe that's up here. Tells you that for every 2 LiCl, you'll use 1 CaS. So first, we actually have to get this grams into moles of LiCl. So to do that, we're going to need to go to the periodic table, Li and Cl. Li is 6.94, Cl is 35.45. We're going to add those two together on my calculator over here. 6.94 plus 35.45, we get 42.39. So 42.39 grams per mole, so that's grams per 1 mole. And this time, because we're not just going to be keeping it with LICL, I'm going to keep writing LICL. And I'm going to attach LICL to every piece along the way here that it's important to. Okay. So now we've converted from grams of LICL to moles of LICL. Can we go from moles of LICL to grams of CaCl2? Well, before we could go from moles to grams of the same thing, but now we want to go from moles to grams of something else. We want to go to grams of our calcium sulfide. So first, we have to change our moles of lithium chloride to moles of calcium sulfide. So this is our new step here that's going to bridge the gap between our basic stoichiometry and adding in our chemical equation component. Notice that every time we've used moles, unless it was given to you, it's always had a 1. Like it's grams per 1 mole, or 1 mole was 6.02 times 10 to the 23rd molecules. This time, this number right here, this mole to mole ratio, is given to you by the problem. We now have to say, okay, well, we've got this many moles of lithium chloride. We also know that for every 2 moles of lithium chloride, we need, or we will use in that reaction, 1 mole of calcium sulfide. So this is like the same thing as saying for every 2 diamonds we use in a sword, we will need 1 stick. It's the same exact type of conversion factor. But now we're converting, instead of from diamonds to sticks and diamond swords in Minecraft, from moles of lithium chloride to moles of calcium sulfide. So now we've converted not just our moles, but we've actually changed the substance we're talking about. So for our last step, can we go from moles of calcium sulfide to grams of calcium sulfide? Yeah, we've been doing that already. So we can put moles of CaS on the bottom, and we can put grams of CaS on the top. And then we'll just need to add up our masses from the periodic table. So calcium on the periodic table is 40.08, and then sulfur is 32.06. So we'll add both of those together. 40.08 plus 32.06. So we get 72.14 grams per mole. Make sure that that gram number goes with grams up top, 72.14 grams in 1 mole of calcium sulfide. So let's actually look and think about everything that we've done on this process here. We started with an amount of grams of lithium chloride. We then said, okay, well, for every 42.39 grams of lithium chloride we have, that is a mole of lithium chloride. Those numbers coming from the periodic table. The periodic table is grams per moles. Then we said, okay, well, now we know how many moles of lithium chloride we have. We also know from the reaction that for every 2 moles of lithium chloride, you need 1 mole of calcium sulfide. So we did a 2-to-1 conversion factor, 2-to-1 mole ratio. Again, this is called a mole to mole ratio right here. That gave us how many moles of calcium sulfide we needed. And then we just said, well, we also know from the periodic table that there's 72.14 grams in every 1 mole of calcium sulfide. So we went from grams of one thing to grams of another thing. All we have to do is plug it into our calculator. We'll do 25 divided by 42.39 divided by 2 times 72.14. And you can type this in differently. You can do it in phases or one at a time if that's still weird to you trying to plug it all in one straight stretch. But 25 divided by 42 divided by 2 times 72. Yep, okay. This should be set up correctly. And we get 21.27270 whatever. But to round it to the correct number of sig figs, we were told 25.0, so we'll need 21.3 grams of calcium sulfide. So because of the fact that it's a 2-to-1 ratio, even though this weighs so much more, we actually only need very slightly less than what we actually need of our lithium chloride. So if we were assuming that every single piece of this is going to react perfectly, nothing will be lost, nothing will not react for some reason, we would be good to combine together 25.0 grams of lithium chloride with 21.3 grams of calcium sulfide. All right. I hope that makes sense to you. I'm going to be sending out the worksheet sometime soon. I think it's going to be maybe 1, maybe 2 worksheets. We'll see exactly how I'm feeling for this week. And then we're just really going to be only focusing on this. This is such an important concept that I really want to make sure that you feel good about it. I'll be posting some problems to do some self-checks, and I'll probably post me working out another example or two. If you have one in the notes or in the worksheet that you really want me to work out, please let me know, and I will try to make it a priority to get that question worked out for you. I hope you have a great rest of your day, and I hope to see/hear from you soon.